is Dr. Karnik with New Age Science Academy, and today's topic is kinetic molecular theory of gases. It is super important for us to understand the concept. Almost all the questions that are asked on these topics are about concept understanding. So let's first look at the kinetic molecular theory of gases. There are three tenets of kinetic molecular theory. The first tenet is size of a particle is negligibly small. So kinetic molecular theory assumes that the volume occupied by each particle is very small, even if that particle has a mass. And that makes sense, right? If you are looking into the volume occupied by the gas, the volume occupied by each of the particle is negligibly small. The second tenet talks about the average kinetic energy. So the average kinetic energy of a particle is proportional to the temperature in kelvins. As we increase the temperature, the kinetic energy of the particles increases. And the third one is the collisions of one particle with another is completely elastic. So basically what it is saying is that the molecules, they don't act like clay particles where they collide and then they get deformed or something. These collisions are elastic. And therefore, when we are talking about the total kinetic energy, which is the kinetic energy before collision and after collision, it's going to be remaining the same. So with knowledge of these three important points of kinetic molecular theory and our knowledge of gas laws, let's look into how to solve questions on kinetic molecular theory. A flask at room temperature contains equal amounts in moles of nitrogen and xenon. So the first question is, which of the two gases exert greater partial pressure? We know that when we are talking about partial pressures, it's important for us to know how many moles of the gas are we dealing with. So let's say if I have a container and if I have fewer moles of gas, so let's say I have just like 2-3 moles of gas, then the pressure exerted by each of these moles, each of this molecule, is going to be less than a container of the same size having more moles of that gas, right? So here you're going to see more pressure being exerted. In other words, the partial pressure of a gas is directly proportional to the number of moles of the gas. So keeping that in mind, which of these gases are going to exert a greater partial pressure? In the question itself, they have given us that both the amount of both these gases is equal. Therefore, the amount of pressure, partial pressure exerted by each of this gas is going to be the same. Now let's look into the second question. The atoms of which gas have a greater average velocity? Velocity depends on the mass of that particular gas. Nitrogen is definitely lighter than xenon. Because it is lighter than xenon, we know that nitrogen is going to have a higher average velocity, right? Lighter particles can move faster. Therefore, it has a higher average velocity. The third question is, the atoms of which gas has a greater average kinetic energy? Now, this is where our understanding of the kinetic molecular theory comes into play. We know that kinetic energy of a gas is directly dependent upon the temperature. And here, in this case, we know that both the gases are at room temperature. Therefore, the average kinetic energy of both the gases is going to be the same. The fourth question is, if a small hole is drilled in the flask, which gas would effuse more quickly? For that, let's understand the concept of effusion. So we are talking about a container wherein this part of the container has vacuum And in this part of the container, you have gas molecules. If I introduce a tiny hole over here in the wall, which is separating this container of gas from the container having a vacuum, if I introduce a tiny hole, I will see that the molecules with the smallest size will be able to pass quickly through here. This movement through this small hole, this tiny hole in this container, is called effusion. And therefore, the particles which are lighter, smaller, are going to have a higher effusion rate. So again, comparing nitrogen and xenon, we know that nitrogen is a lighter particle, and therefore nitrogen will effuse more quickly.